Okay, so now I'm going to show you how to do a parallel circuit. Now, parallel, just sometimes students struggle to remember when is it in series and when is it in parallel. Think of parallel as something where there's a alternative path for the current to flow. So it'll look something like this. There's a resistor, there's another resistor, 200 volts. Again, I'll just use 200 volts. Resistor 1, I'll make it 5 ohms again, and then we'll do resistor 2, and we'll do 7.5 ohms again. So as you can see, if the current were to go this way, it'll get to this point where it will branch into that side and that side, and you can see that the current will then go through the two resistors, get back to at the end, and continue its path and keep circulating like this. Now again, I will put up the formulas. So the first one we got is the triangle, where we got V, I, R. So again, it's for voltage, current, R is for resistance. Or I can go V equals I times R, where I can then use and transpose to get I and R. And again, if you're not sure how to do the transposing, look for my transposing video where you'll find how to do it. If I look at my power formulas, I got P equals voltage times the current, P equals current square times resistance, or I can go P equals V square over R. So there's my unit, my formulas. This will be in watts. Again, all the power is measured in watts, and my voltage is measured in voltage. Current obviously is amps, and ohms, it's just that little symbol there. So again, for parallel, there's a few steps in or rules that I need to remember, and we also got what I call the process as well. So the first one for a parallel circuit, and this is again, like I said before, I'm dyslexic myself, so this is how I remember which formula to use, because according to the Australian Core Skills Framework, we need to be able to identify what is important. We need to then select from a range of formulas, and then we need to communicate, and in this case it'll be whatever the units are. Now for me, to identify which formula to use, I need to know that in a parallel circuit it's one resistor over the other resistor. This is how I remember it, one over the other resistor. So now if I can calculate the resistance total, it's 1 over, and then I go 1 over R1 plus 1 over R2. So you can see it's 1 over the other one, which to me it looks like this, and this is how I remember to use that. Again, if I have more resistors here that are in parallel, I just continue to add them. Now after this, we need to look at the current. My fingers are the current. It comes up, gets to here, the current splits, it goes through through each resistor and comes back together again, and then continue the path. So therefore, the current does not stay the same. It will change. So I can go I total, the total current that would be flowing in here, I total, will get to this point where it will then split into I1 and I2. So the current 1, current 2. So therefore, the total is made up of the current in the first branch and the current in the second branch. Okay, that's the next step. After that, I have the voltage. Now if I look at voltage total, which is the 200, if you look at these lines, can you see that they are all connected all the way to there, and it's also connected all the way to there. So that means that in a parallel circuit, the voltage total is also equal to voltage 1, but it's also equal to voltage 2. Therefore, the voltage in a pure parallel circuit does not change. If I look at my power total now, that equals P1 plus P2. Right, so there's my 4 steps or calculations that I'm going to do, the procedure. That's how I remembered the rules, because important here, the current does not stay the same and the voltage stays the same. So it's the opposite of what we had for the series circuit. Let's do some calculations. So the first step obviously is calculating the total resistance. Now again, like I said before, for me being dyslexic, it helps to use colors, so I'll use the colors again. So I go 1 over RT equals 1 over R1 plus 1 over R2. So R1 is 5, so 1 divided by 5 plus 1 divided by 7.5. Now in the Casio calculator, it's a very easy way to do it on here. If you see there's a x minus 1. So most of the Casio calculators, they have it. Some calculators might have it as a second function. Just have a look on your calculator where you see this x minus 1, because it helps me to do this function when I'm doing the calculations. So let's look at it. If I do 5, I will do 5 x minus 1. See how it does the 5 minus 1. So that now in the calculator is doing this for me, 1 over the 5. I go for the next one, 7.5 x minus 1. Now you'll see that you get a massive or a little value of 0.33 reoccurring. But this is a step that students miss all the time. So what they need to do here is they need to remember that it is 1 over RT from here. So mathematically, if we want to change it, we literally just going to take this and flip it across over. Because really, I have 1 underneath here. So if I flip it over, you can see that the RT will be at the top now, but this 1 now goes above. So it goes 1 divided by 0.33. So basically what you do is once you've gotten your 0.33, don't clear that. Just go to the x minus 1 again, hit the answer button, and it will end up giving you a value of 3 ohm. This basically, hitting that x minus 1 again, basically does the flip for you, and it does 1 over on the calculator, so it saves you from having to do it. What we need to recognize here as well, very important, is that one of the rules is to know that your answer is correct, is that the total resistance will always be less than the smallest resistor. Now in this case we got 5 ohms as the smallest resistor. So this makes sense that 3 equals, the 3 is less than the 5 ohms, which to me means at the moment I've probably done the right correct calculations. So this is just one way of checking as I'm progressing through my calculations.